The first time you looked up at the night sky, it feels endless. The stars seem scattered forever, stretching beyond anything a human mind can properly hold. But the strange truth is that what we see with our eyes is almost nothing. A handful of stars, a thin glimpse of our own galaxy, a tiny window into a universe so large that even light, the fastest thing we know, has not had enough time to show us all of it. When people ask how big the universe is, the honest answer is uncomfortable. We do not fully know. We know how much of it we can observe. We know how far the oldest light has traveled to reach us. We can measure galaxies, map cosmic structures, and study the afterglow with the Big Bang. But beyond the part we can see, there may be more universe stretching farther than any telescope can reach. And that is where the question becomes strange. The universe is not just big. It may be bigger than the word big can even describe. To understand the size of the universe, we have to begin with something familiar. Earth already feels enormous to us. It has oceans, continents, mountains, deserts, storms, and cities. A person can spend an entire life traveling and still see only a fraction of it. But from space, Earth becomes small very quickly. From the moon, it's just a bright blue and white sphere hanging in the black. From Mars, it becomes a pale dot. From the outer solar system, it is almost invisible. The sun, which feels so powerful from Earth, is only one star. It is large compared to our planet, but it is not unusual compared to many other stars. Some stars are smaller and dimmer. Others are so massive they make the sun look almost ordinary. Already before we even leave our solar system, the human sense of scale begins to break. Our solar system is much larger than most people imagine. The planets are not just sitting close together like they appear in diagrams. Those images are made for convenience. In reality, the distances are almost absurd. The moon is already far enough that light takes over a second to reach it from Earth. Sunlight takes about 8 minutes to reach us, but to reach Neptune, light needs several hours. And even Neptune is not the true edge of the sun's influence. Beyond the planets are icy worlds, comets, and distant objects that orbit in the cold outskirts of the solar system. Further still is the region where the sun's wind slowly gives way to interstellar space. Voyager 1 and Voyager 2 have traveled farther than any human-made objects. Yet, even after decades, they are still only at the beginning of the space between stars. That is the first terrifying realization. We have barely crossed our own doorstep. If the solar system is our neighborhood, the Milky Way is our city, but even that comparison fails because the Milky Way is not just large. It is a galaxy containing hundreds of billions of stars, along with gas, dust, planets, black holes, and dark matter. Our sun is located in one ordinary region of this galaxy, far from the center. It takes the solar system hundreds of millions of years to orbit the Milky Way once. That means since the dinosaurs lived, the sun has not even completed one full journey around the galaxy. And yet, when we look at the night sky, most of the stars we see are only nearby stars within one galaxy. The Milky Way itself is so vast that if you could travel at the speed of light, it would still take tens of thousands of years to cross it. But the Milky Way is not alone. Beyond our galaxy is Andromeda, the nearest large spiral galaxy. It is so far away that its light takes about 2.5 million years to reach us. When we look at Andromeda, we are seeing it as it was before modern humans had built cities, before written history, before almost everything we call civilization. And Andromeda is only one galaxy. The deeper telescopes look, the more galaxies appear. And some are spiral like ours, some are giant ellipticals, some are small, faint, irregular galaxies, barely visible even to powerful instruments. The Hubble Space Telescope revealed that the observable universe contains far more galaxies than early estimates suggested, with many too faint and distant for current instruments to fully study. This is where the scale becomes almost impossible. Every distant point of light may contain billions of stars. Around many of those stars may be planets. Around some of those planets may be moons. And all of that is only part of the universe close enough for its light to have reached us. The observable universe. The observable universe is part of the universe we can see from Earth, at least in principle. It is not the same as the whole universe. It is only the region where light has had enough time to reach us since the beginning of cosmic history. The universe is about 13.8 billion years old, but the observable universe is much larger than 13.8 billion light years across. That sounds impossible at first. If light has only had 13.8 billion years to travel, how can the observable universe be around 93 billion light years wide? The answer is expansion. Space itself has been stretching. While light was traveling toward us, the space between us and those ancient sources was also expanding. So the places that emitted the oldest light we can detect are now much farther away than the light travel time alone would suggest. This means the edge of the observable universe is not a wall. It is not the place where space ends. It is simply the limit of what light has had time to reveal. Beyond the observable universe, there may be more galaxies, more stars, more black holes, more empty regions, and more cosmic structures. We cannot see them, not because they are hidden behind a physical barrier, but because their light has not reached us and may never reach us. This is one of the most unsettling ideas in astronomy. The universe we can observe may be only a small part of the whole. There could be regions so distant that they are forever beyond our view, because space between us is expanding too quickly. If that is true, then the universe is not just larger than we can imagine, it may be larger than we can ever measure. Scientists can study the shape and behavior of the universe to make educated guesses. Observations suggest the universe is very close to flat on large scales, which may mean it extends far beyond what we can see, but whether it is infinite or simply unimaginably large remains unknown. The hardest part of this question is not the numbers. It is what the numbers do to us. A human life is measured in decades. A civilization may last centuries or thousands of years, but the universe works in billions of years and distances so vast that light itself becomes slow. The farther we look, the deeper into the past we see. Telescopes are not just looking across space, they're looking back in time. When we observe a galaxy billions of light years away, we are not seeing it as it is now. We are seeing ancient light that began traveling before Earth looked the way it does today. Some of the stars in those galaxies may already be dead. Some of the worlds may no longer exist. The universe we see is a memory, arriving piece by piece. That makes the size of the universe feel even stranger. We are not looking at a single present moment. We are looking at layers of time stacked across space. So, how big is the universe? The most honest answer is that the observable universe is already beyond human comprehension. And the full universe may be far larger. It may stretch beyond every telescope, beyond every signal, beyond every possible measurement we can make from our place inside it. But maybe that's what makes the question so powerful. We are tiny, but we are not separate from it. The atoms in our bodies were forged in stars. The lights in our sky has crossed unimaginable distances. The same universe that seems too large to understand somehow produced minds capable of asking how large it is. The universe may be endless. It may be infinite, but larger than anything we can reach. It may contain regions forever hidden from us. But from one small planet around one ordinary star in one galaxy among countless others, we are trying to measure it anyway. And maybe the most incredible part is not how small we are. Maybe it is that something this small can look into something this vast and wonder where it ends.